Alright class, welcome to the last video lecture for chapters 11 and chapter 12. This is all about using SPSS and reading SPSS output for independent and dependent samples t-tests so we can make a decision and report our conclusions. So t-tests and SPSS. That rhymes. So let's look at a new example. Call this the disco example. It was a study where the investigators were interested to discover the healing powers of disco. So researchers were interested to see whether or not a 3-hour disco dance class could affect overall mood. So they had a sample size of 50 participants, 25 in the disco group, which is considered the treatment group, and 25 in the regular exercise class, which is essentially their control group. And then they measured happiness before and after the classes. So what types of analyses can we do given our scenario and data set? So if we want to look at the differences between groups on overall mood after the disco and exercise classes, what tests do you think that we would conduct? Would we be looking at an independent samples t-test or a dependent samples t-test? We would want to do a independent samples t-test. We're looking at differences between two groups. What if we wanted to look at differences within the disco group on overall mood before and after the disco class? Well, in this case, we're going to conduct a dependent or a paired samples t-test, right? Because this paired sample is the same group of people in the disco class, and we're measuring their pre-scores and post-scores. So let's look at some SPSS output in order for us to examine these two tests. So here's some output for the independent samples t-tests. So our first one is looking at our group statistic. This is simply descriptive statistics for both groups. And so we have our mean and standard deviation for our dependent variable, which is the score on a happiness survey following the intervention, where 10 being the most happy. And we see that it's split up between our two groups, those in the disco group, those in the control group, which is the exercise class. The second table is really the important stuff is. This is our independent samples test, and we see that it's called that from the name of this table. So let's take a look at this table in much more detail. So the first thing we want to look at is Levene's test. This is our test for homogeneity of variances. Remember, we talked about that in part 1 video. And this is telling us how much variances there are between the two groups and if those variances are assumed to be equal, that there is similarity between their variances. And we need to meet this assumption that, yes, there are equal variances. The way that we determine that is by looking under Levene's test and looking at our p-value for Levene's test. And if our p-value is greater than 0.05, right, if p-value is greater than 0.05, then we assume the null, which means that there are no differences, which means that equal variances are assumed. Then we look at the top row and assume equal variances. However, if this p-value is less than or equal to 0.05, then that's telling us we have significant differences. But Levene's test is testing equality of variances. So this would be telling us that we have significant differences between the variances of the two groups, not the means of the two groups, which is what we're looking at overall. Levene's test is the first step in order for us to determine and make a decision using SPSS output. We have to determine whether or not we're looking at the top row or bottom row of our t-test. So in this case, because our p-value for Levene's test is greater than 0.05, we're going to assume equal variances and look at the top row. So let's look at our values here. Since if we're looking at the top row, we see our t-statistic is equal to 5.953, essentially 5.95. So we see our degrees of freedom is 48. And let's pause for a moment. Do you remember what the formula is for degrees of freedom for independent samples t-tests? n1 plus n2 minus 2. Well, if we have degrees of freedom of 48, and if we add 2 to that, well, that will give us 50, which makes sense because they have a total size of 50. So even if we just had this table here, we can figure out how many people we have in our entire sample. Maybe not necessarily between the two groups specifically, but at least our overall sample. So we have our sig, which is our p-value of 0.000. So based on this p-value and comparing this to alpha, would we accept or reject the null hypothesis? Well, if p is less than our alpha, we're going to accept the alternative hypothesis, which means we're going to reject the null hypothesis and state that there are differences. And so since we have significant differences, we want to go ahead and look at to see what is that difference. And we see that right next to our p-value gives us our mean difference. So this is simply the difference between group 1 and group 2. So now we can finally move to step 5, stating our conclusions. So we report this such that there was a significant difference on overall mood between the disco group, mean standard deviation, and the exercise group, mean standard deviation. Our t-statistic of 5.95, 48 degrees of freedom, p-value of 0.000. The mean difference of 2.48 points on the happiness scale indicated a very large effect. D is equal to 1.80. Because we had significant differences, we have to follow up with that last sentence of the mean difference, and then stating the effect size. So we have to calculate by hand Cohen's d, and then state how large or how small that effect size is. So take a look at the video 2 in week 10 to learn how to perform the independent samples t-test within SPSS. You'll want to practice this because you're going to need it for your homework and perhaps your final project. Okay, so we discovered that there was a significant difference between our two groups on their post-test scores. But what if we wanted to see if there was a significant difference between the pre-test and post-test scores of the disco group? Well, this is where we're then going to conduct a dependent samples t-test, just looking at one group of people. So within SPSS, we're going to have to tell SPSS just select the people who were in the disco class and do not include those in the exercise class in this analysis. So we can verify that by looking at the first table, which gives us our descriptive statistics for our sample. In this case, we see our sample size of 25, which makes sense because we know that we had a total sample size of 50 and we had 25 folks in each group. We see the average happiness level before and after, and then some more descriptive statistics, standard deviation and the standard error of the mean. The second table is all about correlations between these two variables. Don't worry about this table. We're not going to look at it at all. But we want to look at our third table definitely, because this is where we're going to get our test statistic and make a decision. So step 3 and step 4. So let's look at this in more detail. So this is going to give us our mean difference between the pre and post test score. And remember that depending upon how we set this up in SPSS for variable 1 and variable 2, this mean difference is either going to be a positive or a negative. But you just have to understand and remember how you set this up. It doesn't matter which way it's going to be, which means that also your test statistic is also going to be either negative or positive, depending upon how you set this up. Now take a look at this degrees of freedom. Degrees of freedom is 24, and we know that definition of degrees of freedom is an estimate of the sample size. Well, how much off are these degrees of freedom from our sample size? It's just off by 1. So our degrees of freedom formula for dependent and paired samples t-test is Bobby the Bear, what is it? Degrees of freedom equals n minus 1. Simply, what is your sample size? Minus 1. And then we see our p-value equals 0.000. So knowing this, we know that we're going to then reject the null hypothesis and accept the alternative and say that yes, there is a significant difference before and after the disco class, and that mean difference of 2.68 that we see here is significant. So when reporting your results for paired samples t-tests, report the mean and standard deviation for each time point, your t-statistic, your degrees of freedom, your p-value. Because we don't do this by hand, you're never going to have a critical value for this, so it's just going to be your p-value that we get directly from SPSS. And then if it's significant, then also report your mean difference, the direction of that difference, the effect size, and then Cohen's d. So here's your template. There is a significant or not significant difference in whatever your dependent variable is before and after, and the descriptive statistics for each of those time points, degrees of freedom, t-statistic, p-value, and then if it's significant, the average increase or decrease, and this is what I mean by the direction of the difference, the average increase or decrease of whatever the difference is on whatever your dependent variable is itself, indicated a small, medium, large effect, and then Cohen's d. So here's how we would state our conclusions. There was a significant difference in the overall mood among participants before and after the disco class, stating the means and standard deviations for both time points. T is equal to negative 6.94, degrees of freedom 24, P is equal to 0.000. The average increase of 2.68 points on the happiness scale indicated a large effect. D is equal to 1.86. There you have it. So you can access video 3 of the zombie data set. You can click here. You can also find it in week 10 to learn how to perform the dependent or paired samples t-test in SPSS. Alright, well congratulations, you are now a t-test expert. Great job, nice work. Alright, so to summarize, independent sample t-tests look at differences between groups, whereas dependent or paired sample t-tests look at differences between one group. Homogeneity variances, which is one of our assumptions for independent sample t-tests and is also known as Levene's tests in our SPSS output, tells us if the variability, your variances essentially, of the two groups are equal or not. The effect size elaborates more on our conclusions and tells us how much of a difference there is between our means. And whenever we're reporting our results for both independent samples t-tests and dependent samples t-tests, we need to include the mean and standard deviation for both groups or both time points, our t-statistic, our degrees of freedom, and our p-value if it's SPSS, or our alpha level if it's hand calculation. If significant, then you report your mean differences and also calculate and report your effect size.